For the graphs below, determine if there is an Euler path, Euler circuit, or neither. The first thing you do is you list all the degrees. What's the degree of A? 3. Remember, a loop is one edge, but degree 2. So A is 3. What's B? 3. C? 2. Why C over here? D and E. How many odd degree vertices do we have? 2. So according to Euler's theorem, we will have at least one Euler path. So we have at least one Euler path, because we have exactly 2 vertices of odd degree. Now we're going to find one. I forgot to write in the directions, find one. Please write that in your directions. So if we have an Euler path, we have to start at one odd vertex and end at the other. Where would you like to begin? So we can either start at A or start at B. B it is. If we're going to start at B, we cannot immediately go to A, because if we do, there's no coming back. So where should we go next? We have a couple options if we're at B. E, I heard E more. And then where? And then we would have to go back to B. So far we want this direction, which is fine. And now we're back at B. Where do we have to go next? A, but we have to use all the edges. A. Hooray! Euler path. There's a bunch of answers. In fact, you can use your friend, the multiplication principle, to figure out how many there are. I would not have you do that, but you can if you're really that bored. So the answer I have versus the answer you get may be a different path, but as long as it's an Euler path, that's fine. So you'll notice in the homework answers it says there's many answers. Here's one of them. Let's try another one. Let's find the degrees alphabetically. A, B, C, D, E, F, G. How many odd degree vertices do we have? Just 2. So we have at least one. I'm sorry? Euler path. We don't want any zombie Eulers. So according to Fleury's algorithm, we would have to start at, for example, F and end at B. So let's start at F. F to where? G. G has to go to A. A has to go to B. Now we have some choices. Where would you like to go? C. And then? Well, why couldn't we go to B after D? Can't end there. Yeah, we have to end there, and we still have some more edges to go through. E has to go to, F has to go to, and D has to go to B. Try this one. Conclusions? Neither. What's the degree of A? And that's the same as B, same as C, same as D. E is degree 4. Since we have 4 or more vertices of odd degree, wah, 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 wah. We have no Euler path. nor Euler circuit. Sad face. Oh, well. I did realize that I didn't make one of the examples in Euler circuit. Would you like one? All right. Questions on this one? All right. Let's see. How many vertices do you want? 6 it is. See. Okay. Give me a sec. I need one more. I call it a flower in Paris. You're welcome. Signed prints are available. $10,000 each. American. What's the degree of A? By 1, 2, 3, 4. C? Really? 1, 2, 3, 4, 5, 6, 7. Oh my gosh. That's terrible. D? 6. E? And so is F. All right, we have no vertices of odd degree. Where would you like to begin this journey of funness? Close. Down a letter. Name one of the first letters in the first 6 letters of the English alphabet. Go. D. Okay, I didn't hear anyone. What did you say? Awesome. All right, C to D. So that one's gone. Next. D to where? Take the loop. Then what? F. F has to go to E. E has to go to A it is. A has to go to D has to go to C has to go to B has to go back to